All right, so hi everyone. I almost said good morning, but it is no longer morning. Welcome to CU Data Week. This week is essentially a free online event where we're hosting a bunch of different talks related to statistics and programming. So the next like 3 or 4 are all about R, whether data management like you are joining today, or we have tonight tables in R, tomorrow at noon figures in R. We're even having machine learning and basic statistics in R later in the week as well. You are welcome to join any and all of the talks that you would like to. At the end of the talk, we do send out an attendance link, and you'll be entered for each talk that you attend. You'll be entered into a drawing to win an iPad, a Garmin watch, or wireless headphones. So don't forget to do the attendance before you leave. And if for any reason you can't join a meeting that you would like to join, we're going to be posting recordings on our YouTube channel after this week. And so make sure you follow us on Twitter or LinkedIn so that you can see when we post those and make those live. But to start us off, I'm going to hand it over to Samantha Roberts. Samantha is a research instructor here at CEDA, the Center for Innovative Design and Analysis, and she's going to be teaching you all how to do data management in R. Take it away, Samantha.
Hi, thank you so much for being here. Like Lala said, I am a research instructor here at CEDA. And let me just share my screen. So today we're just going to go over, I'm going to talk about basic data management R and just also give you some information about R. Okay, sorry about that. So our agenda is first, what is R? How to install R in RStudio. I'm going to discuss the types of objects in R and the different operations. I'm going to review packages and then how you can install them. How to import data. We're going to review the example data that is available on the SharePoint drive that you guys had been given access to. I'm going to briefly go over how to do some data summarization, and then we'll really get into variable creation and transformation, and then how to export data. So to start off, what is R? R is a free and open source software program using the S language. It's useful for statistical programming as well as graphics. And then RStudio is just an easier, more user-friendly environment to use R and to code in R. And then to view your output, you can make reports and different files that you can then use to share with others. So to download R, the first thing you have to do is you have to come here to this link. And I am going to show you that. Okay, so if you follow that link, there looks to be a question in the chat. Okay, awesome.
I'll monitor the chat for you, so I'll let you know if there's any questions, Samantha.
Okay, perfect. So what you'll do is you'll come here. If you follow that link, it takes you to this page, and then you'll click here for the download R. And it'll take you to this page for CRAN mirrors. So what you would want to do, depending on where you're located in the world, you're going to go there. So I'm going to say USA, and then there are multiple choices that you have here. When I did this, I picked Oregon because it was close to where I lived. So you'll click on that, and then there's different download options for Linux, for Mac, and for Windows. So if you have a Windows, you'll go here, and then you'll click here to install R. And then for Mac, same thing. You'll go here, you'll download. I've never used a Mac, but you can see the package here or the link to download. But you also need to make sure that you have exports loaded as well, or else it won't work. So if you are a Mac user, please use that. And then to download RStudio, this link is included in the PowerPoint presentation. So you'll come here. So RStudio, like I said, is just it's just an easier environment to work in with R, and it is also free. So here you'll go, there's RStudio desktop that's free. You'll click download and then you'll come here. And you can pick which, based on your operating system, which one you will be downloading. One thing to know is that R does get updated every, I don't know, like I don't want to say every couple months, but it does at least yearly get updated. And I'm going to go over packages later, and that depending on the version of R you have, some packages may or may not work. So it would be good to yearly, I would say, make sure you have a current version of R. Okay. And then a quick note, R needs to be downloaded for you to be able to use RStudio. And so before I open up R and I don't know why. Oh, there we go. I'm going to talk about some data objects, data types, and operations within R. So there are 6 main data objects within R: vectors, lists, matrices, arrays, factors, and data frames. I'm not going to go through all of these. The main ones that we're going to be working with are vectors, and there are usually 6 types of vectors: logical, integers, characters, raw, double, and complex. We're going to talk about factors, and these enable you to categorize some variables and store the data in levels. And then a data frame is 2-dimensional data with columns and rows. In the presentation, there's explanation of lists, matrices, and arrays, but we're not going to go over that in this presentation. Different data types are numeric values, integer values, logical, character, so text or string values, as well as dates. And so if you have been previously been a SAS user or a Python user, some of the operations in R are different than in those programming languages. The ones that I was most surprised about and that I wanted to highlight here, that is different from SAS and Python, is the symbol for or is just that bar. For and is actually the and symbol. Equal to is 2 equal signs instead of just 1. And when you're going to assign value to an object, you use this pointer symbol. And so now we're going to go into our, sorry for the toggling back and forth. Okay, so when you do open up R, this is what it looks like. So you have kind of different sections within R. You have your coding environment, you have this global environment, you have these different tabs here on the bottom right, and then right below your coding environment, you have your console. So your console is going to show all the code that you ran in your coding environment, and then also shows your results within this console environment. And if you have any errors or anything, that shows up here. So the next thing I want to talk about are packages. So I think my most helpful thing, the reason why I like working in R is because of the packages. So packages are functions, a collection of code, and sometimes data that helps you perform different tasks within R. Some packages are already included when you download R, so there's like base R packages, but there are multiple packages if you want to do different table ones, or if you want to create figures, and even with data management and data manipulation. The library that I use a lot is Tidyverse, and Tidyverse is a collection of multiple packages, including Tidy, dplyr, ggplot. You can look it up. There's, I think, 6 or 7 different packages included. And I use a lot of the functions within this package when I'm doing data management. So there are a couple ways that you can download packages. So let me move this out of the way, make it smaller. everyone. So you can come over here onto the lower right-hand side where it has packages. You can click this install button, and then you can put in whatever package you want to. So I'm going to just show ggplot, and you can see here, click it, and then you'll click install. I already have this installed, so I'm not going to do that, but that's one way that you can use to install a package. There's also already a list here. So you can pull it and you can see what kind of packages are available. I honestly don't usually use that way. In the console, what I usually do, you can do install dot packages, and then you just in parentheses, you can put in the package that you want, ggplot2, and then you'll click enter, and then that will install the package for you. You can also do it up here in the coding environment, but this is usually saved. And whatever you type in here in the console, it is not saved in your program. So you only really need to install a package once. But what you do have to do, if you want to use a package for whatever analysis or data management that you're going to do, you have to call it so that it's included in your library. So to do that, you'll use library, and then in parentheses, you're just going to put the name without quotations of the package that you want. And so there are also multiple ways that you can run your code. You can highlight it, and then you click this run button up here. That's one way to do it. And I did that for a very long time. And I didn't realize that you can do it a much easier and quicker way. You can just highlight and then click Control Enter. And then that also runs your code for you. Or you can even just put the cursor in the code in the line that you want to run, and then also press Control Enter. I didn't know this when I first started coding in R. So for about a year, I was highlighting and then coming up here to run. You don't think that this would take that this takes a long time, but it actually does. So I wanted to kind of go over some of the data types and then how you can figure out what the data, when you bring in data and you have variables, how to determine what type of vector it is. And then how to assign values to things. So here I'm picking X and using my arrow here to assign hello world to it. So I'll click Control Enter. And then if I want to see to make sure that it did what I wanted it to do, I Control Enter. We can see here in the console, that it has the value of hello world. And then again, you can see in the console what I have run and then the results of that. And then, so this class statement here tells you what type of data type it is. So here, I'm going to say class X, and that's a character. So I'm going to go quickly through some of these. So if I want to do a numeric, I'm assigning the value of 2 to Y. We can see it shows up as 2, but this is numeric. And here you can see I'm trying to maybe do a logical, which is a true and false. And so if I run all of this, I actually created a character type of object, and I don't want that. So what I can do, you can change different objects to different classes. So here, if I want to change this to logical, I can use as.logical, the object I want to change, and I'm assigning it to the same because I just want to keep it the same. We go here. We see how here it changed from true to false. This is in parentheses, which shows that it's character, and this is not, which makes it logical. And then you could do that here as well with as.character to change something from to a character object, or as.numeric to change something into a numeric object, as you can see here. So Y was originally a numeric. I changed it to character, and then I changed it back to numeric. So if you look over here on the top right, we have this global environment. So you can see here these values that I've created. they show up here. So it kind of keeps a running list of all the data, of all the objects, of all the different things that you're creating within your program. Are there any questions so far?
There was one question in the chat box that said, can you replace the code in the console for installing a package? And I was wondering if Sarah could expand on her question so that we can answer it appropriately.
Yes.
I think it was install dot something.
Install dot packages. And then in parentheses, yeah.
Okay.
And the cool thing is, if you just start typing that into the console, as you can see, it just kind of pops up for you, and then you can just click it. But it's install.packages, and then you need to make sure there are the parentheses, and then whatever package is in quotations. If it's not in quotations, it's not going to work. And then I did see another question come up about a logical vector. A logical vector is true or false. That's what it is. So it's giving it the value of true or false. And instead of it being like a character, it will show up as true or false. Okay, I'm going to go back to presentation. So next I want to talk about our example data. So what we're assuming here is that we've met with an investigator and they are looking at the relationship between multiple variables of mothers and babies from a maternal health study. And so in order to do their research, they need a clean data set, and they potentially want some additional variables from you that you need to create from the data that you're given. A big thing that I want to say is that you want to make sure that when you get a data file, that it includes a data dictionary. Because a lot of the time, if you get a data file, there could be values and you don't know what they mean, which makes it really hard to be able to manipulate and clean the data if you don't understand what the variables are. You want to be able to know the metrics. So like if it's like if you have a weight, is this pounds, is it grams, height, is it inches, is it centimeters, like, you know, what is the data that you've been given. So our data here, this just gives you some of the variables that are included. So we have the ones that we're mostly going to be working with is weight, which is the infant's weight in grams. We have race. We're going to look at marital status. We're doing mother's height and mother's weight. Mother's height is in inches and the weight is in pounds. And again, that's important because we're going to be creating BMI. And so again, the metric matters because if you need to use a formula, you need to make sure you have the right ones. Some key points that I want you to remember is that do not make any changes to the raw data set that you get. You can open it and look at it, but don't actually, so say you get it in an Excel file, do not actually make any changes within that Excel file because that makes it less reproducible. So I always say create a folder that just has your raw data in it, and then you can make changes, clean, and then export a clean or working data set. So that's kind of like a do not ever make changes to your raw data set unless you do it in some kind of statistical program software. Another thing that I do not like to do is overwrite variables that exist in the raw data set. So for example, here we have something called mom ed levels. This is mother's education level. And we have a 0, 1, 2, 3 category for this. And so maybe you got, you know, your PI wants you to just dichotomize it 0, 1, and 2, 3. You don't want to override and rename that variable the same name, because what if later on you actually want to keep it at those 4 levels? So just always create, I always say, always create a new variable and never override the raw variables. Okay, and this is the last time I'm going to toggle back and forth. So thank you for being patient. And so now we want to import our data. There are multiple ways that you can import data. The first way is here, right? So in this environment, we can go here to import. And so there are different types of data files that you can import directly from this dropdown. So text-based is Excel files as CSV. Text reader are usually text files. From Excel is the XLSX files. And then you can also import files from SPSS, SAS, or Stata. So for us, we're just going to do just a CSV file. And so then you just want to go to where your data is. You'll click it and click open. So if you're taking this from the share drive, this will probably be in your downloads folder. And so this up here is what you're going to name it. I'm not going to have it be that huge name. I'm just going to say birth weight. And then this is how the file looks like coming in. And so what SAS automatically does is it gives that first row is going to be the variable names. And then each column underneath that, all the rest is just the values associated with that variable name. And so once you think this all looks good, you click import. And then you can see here in our global environment, it now exists. We have this birth weight data set right here. And then we can see our data came in, and you can see the different values and all of the variable names. There are two other ways that you can upload data here. The first way is actually just to, for a CSV file, there is a function called read.csv. And then using that, you can, in those parentheses within quotations, you first want to put the path of the, this is really long, the path. So this is the location of your data. And then this is, the name of the data, and then the type of data file it is. So here is CSV. You can see this is all in quotations. One thing that, oh, I lied. I'm going to stop and share one more time. I'm so sorry. Again, I just wanted to share this because I didn't know this when I first started. So if you're in Windows, this is mostly a Windows issue and less of a Mac issue. But if you ever, this is your file, and if you want to know the location, you're going to right click, go to properties, and you can see this location here, and you can just copy that. And then here's like the name, and then here you can see the type of file. So if for some reason you're unsure of that, that's a way that you can determine that. But the main thing that I want to show is that copy and paste is great. But you can see the biggest difference between what you pull from Windows and R is the slashes. So in R, it needs to be forward slashes, and in Windows, it's backward slashes. So you're going to have to go through and change all of those if you're using Windows. Apparently, I heard it's not a problem in on a Mac. So again, you just run that line, and then our data comes in. Another way you can do that is that you can set, if you go to session, you can set a working directory, and you can choose your directory. And so here I'm just keeping it, it's already set to documents. So if I just say, okay, that is my working directory, you can see here in your files that wherever your working directory is, you see all of the different files and folders within that. And so then you could just use this little tilde, and then if you might have an additional file path for it, like I do here, and then the name. So this is just, if you have to upload multiple data sets, this is an easier version, so you don't have to put in this huge long thing. And if you want to do an Excel, this is another one that is pretty common. Doesn't need to be in quotations. Sorry about that. You need this package read Excel, and then the function is read_Excel. Again, it's going to be the file path, the data name, and then .xlsx to upload. And then I love looking at the environment. Some people don't, but this gives you a lot of information that you need. So you can see here this birth weight data. I think I pulled in the clean version instead of my raw. But there are 50,000 observations here. And this is, I'm going to be using this data frame one. And there are 12 variables. So as you create variables, and if you are removing observations for some reason, that you can see that changing here. And then if you ever just want to look, once you pull it in, if you just click on it and it comes up here in a tab. And so you can see all of the variables again and check and look at that. So before we go on, do we have any questions?
We do. We have one that says, I was given a CSV and was asked to interpret it and had issues, so I made a copy of it and changed it to an Excel sheet. Would that be permissible? Still can't interpret it in R, but tried.
Yeah, that's fine. If you need to change, I love that you said that you made a copy. That is really good. You still want to keep whatever the original, but if you need to change the format, to XLSX, that's fine. And I will say that I'm not going to lie, I've also had trouble sometimes pulling in data from a CSV or an Excel. I would definitely what I do a lot is that whatever error is coming up, are you getting an error? You could always Google it. I know that's like the worst thing.
I was told to do that, yeah.
Yeah, because sometimes it could be a problem with how the data is coming in, like the type of character it is. It could be that there's no like first row that to name the variables. There could be a bunch of different things that could be happening there. So, but yeah, that's fine to save it as an Excel, just a regular Excel file.
Just always keep a copy of your raw data.
Just always keep a copy of your raw data. Just go save as, rename it, and save it as a different thing. I just don't change it because say, you got updated data and whatever changes you made into your original raw data is no longer going to be in the new data that you got. And then therefore your data, process is no longer reproducible. So we want to make sure that we have reproducible processes. So just don't ever change the raw data. And I've actually learned this the hard way. So do not do that. Okay.
We have one more question.
Mm-hmm.
Does your data set need to be on your computer, or could it be something that you upload to somewhere online?
I think that that's a good question. It's usually somewhere that, no, you can, it just, you need to have a pathway to get to it. So for example, I use like like a VPN kind of environment, and I use R in there, and it's stored on some other environment, but we're able to connect it within the file. So you want to just make sure that there is a pathway to be able to access your data. Any other questions?
That was it.
Okay. So now I'm just going to kind of do some basic data summarization. So one thing that you can do, this isn't always helpful, depending on the kind of data that you have, but you can just do this function called summary and then just use df. So this is just looking at your whole data set. And then you can just see here in the console, it gives you kind of a view of your data. And what it usually gives you is assuming these are numeric, which most of them sort of are. And then, the mean, the median, the min and max. But the reason why this isn't always helpful, like I know weight is a numeric, but I know married and boy is actually categorical. There's only zeros and ones. So this doesn't really give me much summary of that. One thing I want to make clear is that this isn't a problem with, at least I know with SAS, is case. The case is very important in R. If the variable has a capital W and then lowercase EIGHT for weight, if you don't include that capital, so here I'm going to run this, it's going to say this doesn't exist. The length is 0, class is null, mode is null, but you're like, no, I know that exists. if we change it back to a capital, now we have a summary of this weight variable. A key thing here for when you're doing coding in R is that you could, like we have here, multiple data sets. So you want to make sure you use whatever the data set is, this $sign, and then the variable name when you want to like work with or look at a specific variable. And then the summary gives you just the summary here, just like what we did with the full data set. If you just want to see like the first like 5 observations of that variable, you can use the function head, and it shows you the first 5. And then again, class here, we want to look at class. So if we come back into our console, we saw here race is a character. And so if I want to look at race and to kind of see what just an overall view of what that variable looks like, I can use this factor. So summary, factor, and then whatever variable that you think is in levels that we know that race is, then that gives us a more, just the numbers of each group. And so the one thing I want to bring your attention to is this 127 just has a blank space over it. So it's a value of nothing, but because of how the data was read in, this is R is not considering this a missing or an NA value. R counts missing, shows it as an NA. And so you can see that with, if I do a summary of the mom weight here, we can see we have the min max, and then we have these NAs here. So that means that we have 81 missing. And so another way that if you want to see how much is missing for certain variables, and then you can see how this difference here, that this 127 isn't considered missing where this 81 is. You can do this is NA. Is NA is calling like what is missing within this variable. And then sum is just summing it. So how many are missing with mom weight? So if we run that, we can see it's 81 that matches. But if we do this with race, it says 0 because it's not counting those spaces, that 127 as a missing. So these are the type of things that you want to use to kind of look at. And this is obviously something that we're going to have to clean up because there is no race of just a space. So we need to say that this is actually missing. So another way, so instead of doing all of these individual summaries per variable, if you want to do a quick, I just want to view everything in my data or whatever variables that you're interested in manipulating and working with and cleaning, you can do this table 1 function from up here, this table 1 package. So if you go to the seminar later today, Grace is going to give you way more interesting and cool ways to create table 1s, but this is just a quick and dirty, easy way to create a table 1 so you can just view your data. So what you're going to first do is put this little tilde here. And then since I know race is a leveled variable, I'm going to say factor. If you don't, then it's not going to work. For example, I also know married is a level because from my data dictionary, I know it's 0, 1, 0 meaning no, they're not married, 1, they are. So I know it's a level, so it's a categorical. So I'm going to put factor in front of it. And then you put the plus sign for every variable that you want to include in your table. So we have mom weight, mom height, weight, and then factor smoke. And then you're going to be data equals, and then whatever data frame that you're going to be wanting to summarize. So we're going to click that. And then over here on the lower right-hand side in the viewer, you can see here we're given an overall table of our variables that we're interested in. So we can see here, we just have this blank space for race. And then these are our levels within race. What I like about this table 1 more than just doing a summary is that it gives the amount plus the percentage, which is just a lot more helpful than just the basic number when you're looking at categorical or leveled variables. And then for the numeric, it gives you not only the mean and standard deviation, but it also gives you the median min and max as well, which again could be helpful, and then lets you know the missing. So here we can say mother's weight is missing, mother's height, there's some missing, and then the baby's weight here, we don't have any missing, and then mom's smoke. So this is a nice way to kind of get an overall view instead of looking at individual variables like one at a time. Okay, so
You have a couple questions, Samantha.
okay.
The first one is, what does the tilde do?
So it's just saying that these are the variables that you're using in the you want to include in the table. It means something different depending on what kind of function. So in this case, it's just saying these are the different factors or the variables that we're including. You could also do, instead of looking at it overall, you can look at it by some other variable. So say you wanted to look at mom smoke and the different factors potentially associated with mom smoke. To do that, you would actually put the bar, and then this would create it by mom smoke. But in other functions, you would actually put the mom smoke here. So it's saying mom smoke is going to be your columns, and then here are all the different factors. So for this case, this is like, these are the variables we're including in the table. In other instances, it's like, it's going to be this variable looking at all of these. So it just unfortunately kind of depends on the function that you're using. But the great thing is, so if you're ever unsure on how to do or what a function does, you can come down here into the console and you can do question mark and then table 1 and then click enter. And then click enter, there we go. And then over here on the right, it gives you, table 1, like information of what all the different arguments are within that function. And it also gives you examples. So if you're ever unsure of like how to do stuff within a function, this I've always found really helpful. And again, it's something I didn't know when I first started. And so that is another way that you can check. But here it's just saying all of these variables are going to be included in the table. Any other questions?
I think those are all the main ones so far.
Perfect. Okay. Okay, great. So what I next want to do is, when we were talking to our PI, what they're really interested is in looking at low birth weight in babies. And so we want to create that variable. But what we have is we have weight in grams, and it's just a numeric variable. So what you can do is that you can actually create a variable based on a dichotomous variable or a multiple categorical variable based on that numeric variable. So a really easy way to kind of do, if you're just doing a dichotomous, is this if-else function. So here I'm creating a new variable in the df data frame, and I'm calling it low birth weight. And then here I'm assigning. So if-else is basically what we're saying is that if this statement is true, I'm giving it a value of 1, and otherwise it's given a value of 0. So here I'm saying if the weight of the infant is less than 2,500 grams, we're saying 1. And in my case, this means yes, we have a low birth weight, versus no, they're at normal weight. So that's one way that you can create kind of more leveled categorical variables from numeric. Although this, if you do the class of this, it's still going to be labeled as numeric. So I'm going to show you how to create that factor later on. And another one that you're probably going to have to use a lot is calculating BMI. So again, in the data frame, I'm making a new variable called BMI. And then this is just the function or the formula. You can Google it on how to do it, but this is going to include mom weight and mom height. And so I can highlight all of that, Control C, and run it, and then kind of see what this looks like. And then we see here we have 154 NAs. which we can say that makes sense because we have some missing mom height and some missing mom weight. So it would make sense that if we don't have a height, we can't get a BMI. So we have that missing here. And a lot of the time, I don't just want the BMI as a numeric. I actually want to make a category of it. And so this is my absolute favorite function of all the functions I use when it comes to data manipulation and cleaning and working with variables is this case when. So this allows you to make multiple categories based on different arguments. So here I'm naming this BMI cat. And so just with the general levels of what BMI is. So if BMI is less than 18.5, I'm giving it the value of 1. So that's what that tilde is saying. We're saying if this is true, this is the value that I'm giving it. So you can see here, tilde here means something a little bit different. And then here we can say, all right, well, if the BMI is greater than 18.5 and less than 25, we're going to give it a value of 2, and so on and so forth. And then here, I actually want to make missing its own category because I just really want to kind of maybe understand, why it's missing. So a way that I can do that is I can just do is.na, which is saying this is missing, and I'm giving it a category level 5. I'm gonna run that really quick. And it's all blue, so good to go. There are no issues. So another way that you can use if else is this issue that we had with the race cat, where we just had this space here. That wasn't helpful for us to, it doesn't mean anything. So we want to give it that it is actually missing. And so in R and A is considered missing. So I'm creating a new category because I don't, again, want to override my original variable. And then if else, again, if this statement is true, we're going to give it an A. Otherwise, we're not going to change anything. We're going to leave the variable alone. So we just want to whatever already exists. I use this kind of argument pretty often. So again, it worked. And so once I'm going through and recoding and making all these different variables, especially something like BMI, because sometimes it's like it's unclear, do you need an and or do you need an or? And so what I like to do is I like to create my own data frame looking at just these specific variables that I'm changing to make sure that R is doing what I expect it to do. This is just a good way to check to check your code that you're doing it correctly. So you can create your own data frame with the function data.frame, and then you can just include whatever objects you want to use. So I could pull, say I had a value that was the same length as my, has as many observations as my data frame. You can include that in here. But here I'm just pulling these 2 variables from the DF data frame to create my own data frame called check. And then I can look at that here. And yes, okay, so right off the bat, I see BMI is missing and it's a category 5. And then you can scroll down. Sometimes it takes a second. I'm going to give it a couple more seconds. If it doesn't load, then I'm going to move on. But this way you can see, okay, if I have a BMI of 18.56 or 18.6, that should be a level 2, right? Because it's not our underweight, it's our normal weight. So this is a way to check, is this doing what I expected it to do? And is it really doing at the boundaries that I set? I find this really helpful. I do this all the time when I'm data cleaning. Again, just as a check for myself. And then here I'm going to look at, the sum of what's missing in BMI and did that, this is another way to kind of check. It is in 154 in the category of 5 as missing. You can also create these dummy variables. So say I wanted to race, but I really wanted to look at black or other and everybody else, or white and everybody else. So this is another way that you can just create some dummy variables. And then if else, again, the statement, I'm giving it a level 1 versus a 0. Now, there's another whole different way that you can do this. So you can see up here, it doesn't seem tedious now, but having to put this DF $ up before every single variable that you're looking at, one can take, if you're going to be manipulating, 60 different variables or even 30 or 20, it can actually add up. The time adds up. And if you forget this DF $, it would mess up your entire code and it's just not going to work. And again, so a way that you can do that is actually using tidyverse. I'm not going to go into too much detail here. There's a lot of documentation. The great thing, another thing I really love about R is that there's a lot of documentation on packages, on functions. There's so many websites where you can ask questions or find questions that have been asked and get the answers. But this is kind of how I usually, when I'm manipulating multiple variables, is actually using this piping function in that's available within tidyverse. So here it's saying like, this is the data frame that I'm creating. As you can see here, I'm not creating a new one. I'm just saying, basically I'm changing the old one. This is the data frame that I'm pulling from. And then this mutate function is saying like, these are the things that I'm going to be changing. And so here you can see it's all the same things, except I don't have to do the DF $ in front of every single one. So it actually goes a lot faster. And then also a big difference, you don't use the arrow, you actually do equal signs here. And I didn't point this out before, but when you're gonna be saying race, you have to say equal equals, or anything is equal equals and not just equals, because if you just only have one equals when you're working within the variables, it's not going to work for you. And the good thing about piping is that you can, after this, I can add another pipe here and do another function and do another function and do, like, I can stack on top of each other, which is, again, can be very helpful and quick. Okay, so the next thing, I'm going to try to go through this very, very fast, is this factor function. This is also something I use quite often. And so we created that low birth weight of 0, 1. And if I were to do a class of that, right, it's going to sit here and it's going to say it's numeric, right? But we all know that it's not numeric. But so therefore, I'm going to use this factor function to create a new variable called low birth weight cat. And so what you're going to do is you're going to, whatever variable that you want to change into levels, you're going to put it in here. And then this is also what I really like to do, because a lot of the times just having 0, 1 isn't particularly informative when I want to look at the, when I want to review that variable or even the data. So here we can say the levels are 0, 1, and then the labels you put in here. If you have multiple levels of anything, whenever you're working in R, you're going to use this C and then parentheses, and then you're going to, however many levels you have, you're going to put it separated by a comma. And then here we have labels, and then we have the normal weight, low birth weight. To be clear that this has to match up with this, like that's what it's going to assign. It's assigning 0 to normal weight. And also, if you, for some reason, want like 1 to be first and 0 to be second, you would actually have to switch them. And so for BMI cat, we're changing underweight, normal weight, overweight, and then mom smoke, I want to say yes and no. So all of these factors. You don't always have to go about doing this. We know our race cat already has names for those variables. So I'm just going to say, the factor of that. And so if we look at this now, we can see we have our NAs here. And then I just included the dummy variables again. You can do factor. And then you can also create variable names for your variables. So how we showed our table 1 over here, everything is still the variable name. And again, sometimes it might not be very informative. If you have a variable name is Q2 and Q2 means mother's weight, you would want to assign it a label. So here, what you would just do is you do label, you put in your variable, make sure you use the correct data frame, And then this is assigning the value of, here we're saying low birth weight is less than 2,500 grams, or just low birth weight, or all of those. Click all blue. Great, we're doing a good job. And then you could do a table 1 again. And again, we're just, because all of these, we've already, all of our categorical leveled variables, we already assigned it as a factor data type. So now we don't have to include that when we're creating this table. And then see, this looks a lot better when we're looking at it. It says race, and then we want to look at black and white, although this is 0, 1. So I might go back and change that. So using a factor to say what the levels mean, we have low birth weight, body mass index. So this is also just a really nice way to make your tables prettier for yourself. If you need to come back to it later, you know what you did and what it all means. And so if you want to create a clean data frame, you can select out. So again, this is from Tidyverse. This is a dplyr function. You can select whatever variables that you either want included in your data frame and in a new data frame that you're creating. Or in our case here, I'm like unselecting. So I'm getting rid of. So if we look here at our data frame, we've created 23 variables from our 5,000 observations. So here I'm making a new data frame called df clean. And I'm going to run it, and I'm getting rid of mom age and mom weight gain. So here I have this new data frame, and I have 2 less variables. This again is really great. You can also filter by like specific values of variables. So if you want to like subset your data to a certain population, Tidyverse is awesome. And there's so many helpful functions in there that I unfortunately didn't get to go through here. And then if you're going to export your data, it's similar to the importing. You know, you're going to have something called, you know, it's going to be write CSV or write this or write that. First thing, the big difference here is that you're going to call your specific data frame that you're going to be exporting. And then again, in parentheses, you want the data file. And then make sure you create a new name. You could even put like a date on it so you know when you created this. And there you go. It exports out. And that means I did it. And that is it. Sorry, wanted to leave some time for additional questions.
We do have a couple in the chat box. If you reshare your screen, I think I know where this question came from, but one person's asking, instead of the tilde, can we use a comma to assign the values like we did before for if else? So if you share your code, I think I know where that was.
I'm assuming for case when here.
I think it was above this, but yes, I think it's basically referring to that part of the code.
So it depends on the function. So no, you can't use a comma here. It has to be a tilde when you're using the function case when, versus if else it is just a comma. These are by no means the only 2 ways to create variables. But these are the 2 functions that I use the most in my experience and tend to be the easiest. But yeah, unfortunately, no, you can't do a comma because here this comma means something different, right? So this is saying this is the first category, and then we need to distinguish between one category to the other or one level to the other with the comma. So like if I didn't include a comma here and I run this, it's going to say what's happening, you didn't do it right. And even if I put a comma here, it's going to be this is not right. It doesn't make sense. So specifically for case when, you're going to use the tilde versus an if else, it just is a comma. And you also don't have to just put like a 1. If you wanted to, you could, in parentheses, if you wanted to create a character, you could just say yes. And then also here, create no. And again, you can also do that here if you didn't want to do a factor later, or you're using this for multiple people and you're kind of using this cleaning as your data dictionary. So either way you can do it. I hope that answers. I'm sorry. Sometimes it depends on the function.
That's R for you.
Yes. That's the only negative thing, is that it's not like super consistent. And
yeah, it's not uniform like
yeah.
SAS, which
like
I
SAS
teach.
is super uniform, but R not so much.
Another question that goes along with the lines of uniformity in code. Why do you select on line 89, you have an equal sign after the BMI cat? When do you do an equal sign versus the little arrow?
That was a mistake. It should be an arrow. An equal
Cool.
sign does work sometimes, but it should have been an arrow. That's my mistake.
Cool. Do you have an explanation for why it should be an arrow, or it's just the way it is?
I don't know. If I'm going to be completely honest, that was just how I was told. And I know that sometimes using an equal sign is fine, but sometimes it's not. So just unless I'm using this, these were just oversights on me, and it worked, and it obviously was fine. But most of the time it needs to be that you use the arrow, unless you're within this kind of piping mechanism. I wish I understood why, but I don't. And I've done it where if I use this, it doesn't. If I use an equal sign, like, it doesn't work. And again, it depends on what you're doing. But that's an easy thing. I mean, the biggest thing is that the more you code, and if you're doing a lot, and you like run a bunch of things, and then it breaks somewhere, and it could be something as simple as this, and you just don't catch it. So I just try to be consistent. I know it doesn't look like this. I usually never make that mistake, but just you want to be consistent so that that's not the error that it is. But yeah, unfortunately, a lot of times it's like you don't have enough parentheses, or you have too many parentheses, or you have an extra comma when you shouldn't have a comma. It is a little bit finicky. So a lot of the times if you come up with an error, you're going to like bang your head, and it's usually like you forgot a comma somewhere.
Another question, is there a character limit for variable labels?
I have not come across it. So I want to say no, because it's just going to put in whatever. And another thing, like depending on the package, how you label is different. So this is specific for table 1. I've had it very, very long before, but you have to also kind of keep in mind that it might cut off when you're viewing the table. So you also want to kind of keep that in mind. If you have a 2-sentence long title for a label for a variable, it's not going to show up nicely in your table, no matter, even if you export it as an HTML. And that's also something to keep in mind when you're working with like titles of a table or figure legends, like all of those things. There's sometimes just not the space to include it. So it's probably not going to give you an error, but it probably won't fully show up when you're viewing it.
I think those were all the questions that we have in the chat box. Are there any that are lingering for people? If not, please follow us on LinkedIn or Twitter, or both. I will be posting the YouTube link once we upload the recording to YouTube. And then Samantha's going to update the code on the OneDrive so that you all have the latest version for when you're studying after this.
Yeah.
But thank you so much for joining us, and thank you, Samantha.
One second, I'm putting the link for the attendance in the chat now. So please make sure you go and click on that so that you can get into our raffle and maybe get a cool prize.
Thank you, Samantha, for teaching today. I appreciate it.
No problem. Bye.